let's finish the rotor. So I want to convert this omega into not revolution per minute. Let's do radians per second. So I know that one revolution is 2 pi radians, and I know that 1 minute is 60 seconds. That gives me units of radians per second, which is a number that I can actually use for this omega and plug into the calculator. Everything's the base SI units. That's good. Okay. Here, let's get into that. So it's 25 times 2 pi over 60. So this omega is actually 2.618. That's radians per second. So that is radians per second. All right. Now, I think that for this guy to not slip off, this friction force has to be at least as big as this weight. So I would want the friction to be equal in magnitude to the weight. Okay. Now, here, a little thought cloud over here. I know that friction force can be coefficient of friction times the normal force. Okay? If it's kinetic, it's equals. If it's static, then this could be an inequality, or I could say the minimal necessary coefficient of static friction, which what I'm going to do. Okay? Right, so what I can do here is, okay, because I need to somehow bring this angular speed, I'm thinking about this force right here. I can rearrange this to get the normal force is equal to the friction force divided by coefficient of friction. Okay, now what's that going to be helpful for? Right, because actually, I should have said this minus this is equal to 0. Friction force minus mg equals to 0, which leads to this. I'm going to use this as a substitution here in a moment. Okay? Right, so something to do with, I need to somehow bring in this, the angular speed and so on. Okay? So I'm going to say that this normal force is acting as the centripetal force. Right? So something like that. Right? Now this normal force, well, I know is equal to this expression right here. So that's like friction force divided by coefficient of friction. And the centripetal force, I can use this right here, right? M omega squared R. Right. Okay, so now I have a way to include this omega that I found up here. I got that. It's R. So what else do I need? How about this friction force could be equal to the weight. Okay, that's the other substitution. Is it this right here? Friction force is equal to magnitude to the weight. Right there. Okay. So I need to solve for mu. What I'm going to do is cross multiply the mu and take this whole expression and divide it down. So right here I have, this would be mg from here, mg. Then divide it over this m omega squared r. And that'll leave me with the necessary minimum coefficient of static friction. The mass of the guy, they never mentioned the mass. Because it cancels out. Doesn't matter, light person, heavy person. Okay? Everything else is just this. So the necessary coefficient of friction is, so g, pick your favorite, we would use 10 meter per second squared. Omega is 2.618 radians per second, rad per second. Now that's all being squared. And this radius is 3.5 meters, 3.5 meters. Right, divide down there. This is the fresh part. Let's get a number right here, right in the corner here. Okay, so what's the minimum necessary coefficient of friction? 10 divided by, and then a bunch of parentheses here, 2.61835. Okay, is, but kind of square that. Square the, I get it lost here. Yeah, that looks about right. 0.42. Yeah, that looks pretty well aligned with reasonable coefficients of friction. So there you go. As long as the coefficient of friction is about 42%, say friction force is at least 42% of the normal force, the guy will stay in the ride.